In our previous episode, we had the catching title, Now I'm Worried If Our Metrics Are Correct.
Yes, we did. That was when we were talking to Holly, right?
Yeah. Narrator, they weren't. They weren't as bad as we feared, though. So we did indeed have a misconfiguration, but the effect wasn't catastrophic. And we should say, in our defense, we did test this with a few packages before making these runs, obviously. But you inevitably miss edge cases when you go from, like a handful of packages to 7K packages.
Sure.
But yeah, I found it really interesting how that was triggered by our conversation with Holly when I did the little quiz, right? And Holly went really low in how many packages she thought might have be reporting
Right.
zero errors, and I think you were pretty close.
Yeah, I think I was within 1,000 or something like that.
Yeah. So the percentage I quoted was 53.2% of packages reporting zero errors. After our last run, it's lower. It's 40.8 packages. So it is a large correction, but it's also not like, like 10% only. It's like a significant drop, but it is within the ballpark. It's still, there's still issues that we see, right? Latest one had packages that we are known to be Swift 5 compatible, well-known packages that don't build in the Swift toolchain. So they aren't reporting zero errors because the build fails. So this number is also, there's never going to be a correct number. We're just going to try and do our best to approach a number that has a good reflection of what the ecosystem looks like. And that's a matter of both the tool chains improving over time, because we have to bear in mind these are preview tool chains. So they will have issues of their own. And we've actually seen some of them pre-runs in our testing, and we found some workarounds for those. And there's also, the aspect of packages working on fixes and having just things that break because of the nature of Swift 6 being,
of course,
in preview right now. So yeah, that was a little follow-up on that, on the episode title.
Well, the most important part is that it didn't change the outcome of the quiz, and I retain my quiz champion title.
Oh, there we go. Points awarded.
We should actually talk about two other data points on that chart that we're going to. If you've been following along through pull requests, because it's not live on the site yet, you may have noticed that there are two data points at the beginning of the current chart which are very out of sync with the rest of the data points that we have there. And we're going to remove those two data points because there's always a question with when you put a chart like this, is it going to mislead people? And that's we do not want to mislead people. That's not our intention. The first two runs of the compatibility testing that we did, we were only able to get working Swift build commands rather than Xcode build commands. So that took us down from our current list of platforms, including iOS and watchOS and tvOS and iOS and macOS using Xcode, and it took us down to Linux and macOS using Swift build. And that was interesting data to have at the time because it gave us a sense of some numbers, but also it let us test this process of running all of the builds past the Swift 6 toolchain. So it was important that we did those. But actually, it's those two data points that are misleading. And so we're going to knock them off the beginning of the chart so that the chart doesn't mislead. It looks like everything got a lot worse on the third one, but actually, in reality, we just didn't test all the platforms until the third one.
Yeah, exactly. We had like a snapshot, a slice of the full picture, really only in the first two runs. And as you say, it was really useful to get us set up and running. I think it's always great to just get the process going, right? In that case, especially because it was quite involved. Just the fact of the act of running it was really helpful, but the data isn't I mean, the option obviously would be to just keep doing that only, right? Then it would be comparable, but that's also not a good result, right? To only look at SwiftPM builds across those two platforms. So since we can't go back and run Xcode builds for the old ones, that's really the only option, is to just discard those and just start from what we've got.
We kind of could, because we could install the old. Oh no, we can't, because those old. It was we couldn't.
Yeah, there was.
We can't run it with those tool chains. Yeah, it's just not possible to do it. Yeah.
Yeah.
So, and I think that page is going to go live fairly shortly. I think maybe this week even we might put that page live to start publicly tracking the Swift 6 status of all our packages.
Yeah, that's great. And we'll probably have another data point in 2 weeks. So I looked a bit at the calendar to plan these a bit. And I think every 2 week cadence is realistic and doable and interesting as well, to space out the points a bit and give us a view of trends and stuff.
And part of what is making that 2 weeks cadence feasible is some other news that we're not going to talk about in depth today, because we will talk about it in depth on a future episode. But I think it's worth a little tease now. We have a new macOS build environment for all of our compatibility builds. So one of the ironies of our build system is that the Linux builds were more isolated and more independent of their environment than our macOS builds, because our Linux builds use Docker. And so every time you do a Linux build, it spins up a new Docker container and does the build and then drops the container and everything's back to as it was before. But with our macOS build system, we were running bare metal Macs. And of course, we then run lots of builds past the same versions of Xcode on the same machines, but they don't have isolation. They don't have the kind of the well, this is isolation. That's what they don't have. They don't have isolation. And we've been working with Mac Stadium for the last couple of months to fix that problem, basically. So we're moving to an Orca-based build system, which is their Kubernetes orchestration system over, but for macOS host machines. And so we will talk about this more and the whole setup, because it's actually quite a fascinating process. And we've ended up with this quite robust build system out of it. But one thing that these Swift 6 builds that we've been doing have been an amazing test of that system, because the last 2 runs of the Swift 6 compatibility builds have all been through our Orca cluster now. And it does give us complete isolation. So for every single Swift build or Xcode build that we do, we spin up a new virtual machine, a full VM, not a Docker container, because we need the full VMs. And we do the build, and then the VM gets destroyed and goes back to the base image, and then the next build starts a whole new VM, and we can have VMs configured for different operating systems, like Xcode 14s need Sonoma. No, I'm getting that wrong. Some operating systems need some specific versions of Xcode. And we can have that. So we can have like a Swift 5.9 image that has the right operating system and the right version of Xcode. What's even more funny about what I just said is that I was the one set those up. So there's no excuse for me not to know the pairings, but they're hard to remember. So yeah, we've been running this as a kind of test for the last couple of runs. Our current production builds are still on our existing system, but I think we're at the point where we could switch over to that new system imminently.
Yeah, absolutely, because we ran from the same queue. We triggered builds on both systems in parallel. So all we did in our preview runs is that Swift 6 builds we sent to Orca, while all the other builds went to the old build system. And changing the targeting is just a matter of changing some labels in the in the runner setup to send the other builds to Orca as well, or distribute them wherever.
Again, we shouldn't talk too much about this, but this enables us not only to get more reproducible results and more stable results because of the isolation and the security. It means that those builds can't do anything to our systems, which would have theoretically been possible in our current system. We were lucky never to have that problem, but we were a little open to it, even though they ran on non-privileged accounts and all. There was other things like that we'd done to lessen the impact of that. But it also allows us to plan more features for the future. Like, for example, we could potentially include more dependency setup inside the virtual machines because it wouldn't be necessary for every build to run in that environment. So we're not announcing anything there yet. We're not even committing to that feature, but it does enable it enables interesting future directions.
Yeah, and that's actually another point where Linux is in the advantage currently, because that's what we actually support there. We have a couple of repositories that need specific Linux packages to be system or OS level packages to be installed in order for them to build successfully. And the way we allow that is we allow them to specify pre-built underlying images that are used instead of the Swift6 image to run the builds, so that they have their environment set up as they expect, and these are just used for those packages, so they don't influence other packages, and that's a great feature and great flexibility that we might potentially gain on the macOS side as well. I think one of the problems that's always going to plague the macOS side a bit is that these images are just huge.
Yeah.
Versus, the Linux ones aren't tiny either, but Mac takes that to a whole new level in sheer image size.
I believe the images are currently 90 gigabytes.
Yeah, that's almost 2 orders of magnitude more than, well, it might even be more than 2 orders of magnitude than the Linux images. So that is significant, and
which makes it even more remarkable that these VMs spin up in about 3 seconds.
Yeah, or even the cold start, when the image needs to be fetched, isn't that terrible either.
Cold start is about 3 minutes, isn't it? Yeah.
Yeah.
Anyway, we'll spoil talking about this on a full episode if we talk more about it. So let's move on.
Let's do it. There's another bit of news that is sort of related to our last episode, and that's an accepted proposal, SE0435, which allows setting Swift language version per target. Now, if you recall, we talked about this in our episode with Holly. We mentioned there that you need to opt into Swift6 language mode in order to fully adopt concurrency checking or set the flags, but opting into the language mode is the easiest way to do that. Now, previously, this was only possible on the full package level. So this was an option in their package manifest. You could set the language version, but it would apply to all the targets in your package. And with this proposal, you can actually do this on a target by target basis, which is great if you want to transition slowly. You might have lots of targets, some of which are harder to transition over, and then you can just pick your battles, switch the ones that you can want to start with early, and then leave out the ones that might be more complicated to do. So that's a great thing to see in place. So that's accepted, and I think that automatically comes with a implementation and should be in toolchains soon.
Fantastic.
Right. In other news, do you know what a flipper zero is?
It's what a dolphin does when it wants to get your attention.
Right. I'm not sure how that relates to Swift, but the Flipper Zero I'm talking about is a portable multi-tool for pen testers and geeks in a toy-like body.
That's that kind of Flipper Zero. Of course I knew what that one was.
Yeah, there you go.
I thought that one was too obvious. Yeah.
Right. So it's a little microcontroller device with a screen and a D-pad, and it has a C API, and I can probably see where this is going. This is another one for the section Swift in unusual places. Samar Sunkaria posted on the Swift forums about this a proof of concept to target this device, and add a Swift API layer on top of that C API to be able to build apps for this. So ship binaries to this microcontroller thing. It has a display and a D-pad, so I'm not sure actually what you could probably ship Doom on it, but this might be interesting in terms of getting more stuff on it to do what this is actually intended for, like pen testing and that sort of thing. I found that interesting. I found it especially interesting that we've seen this embedded Swift popped up, was it like 3-4 months ago? And since then, there have been like at least three proposals or implementations I can think of where people added APIs using Swift over C APIs and shipping this to these microcontrollers. So that's really interesting, and I hope that trend continues and becomes more mainstream. I found that really nice to see that this is really being picked up.
It's always nice to see it arrive on a new platform. Yeah.
Yeah. And I think it goes to show that this is really powerful to be able to sort of insulate people from the C API. I mean, I get why these ship with C APIs, because that's the most platform agnostic thing to do, right? Or I guess one of the most platform agnostic things to do as a vendor for this thing. But then the ease with which apparently people can layer on top richer or different language adaptations that make it easier to work with. I think that's a superpower, and I hope that gets used a lot and becomes more popular.
And you mentioned running Doom on on it. That reminded me of a story I saw recently that somebody got Doom running on gut bacteria.
On what?
Which was a story, gut bacteria.
Like in a simulation or actual?
No, in actual gut bacteria at a resolution of 32 by 48 pixels. Unfortunately, the cells take 70 minutes to illuminate and 8 hours and 20 minutes to return to dark. But through manipulation of gut bacteria, they did get Doom running on the gut bacteria.
So in terms of frame rate, that's not going to be great, is it?
It does say here, it says, given that the original game runs at 35 frames per second, the cell display would take 599 years to play Doom from start to finish.
Oh, God. That still sounds quicker than I would have thought.
We'll include, as a completely relevant link, we'll include a link to that in the show notes.
Fantastic.
But you really can play Doom on anything, yeah.
That's amazing. You've probably seen the one where they ran, I think it's Doom, where they run it on the CPU load widget on a supercomputer.
Right, yes.
So someone has a panel up with however many CPUs that thing has, arranged them in a grid, and then just by creation of load on the system, they light up the pixels. Yeah. It's kind of nuts.
Yeah, I love that it has become a thing.
Yeah. Great. We got another one for our different segment, which is Swift on non-Apple platforms. And this is a post by Jeremy Day from the Browser Company about Swift tooling on Windows. You may have seen this one, Dave.
This was a few weeks back, right?
I've seen this last week. This might be a different post than you're thinking. Yeah. So this is specifically about Swift tooling. It's not about how they implemented Arc, which is their browser and the Browser's Company main product, which is known for. It's implemented in Swift on Windows. So they ship this whole thing. This is about the state of tooling on Windows. And it sounds like things are going really well over there. And I've been actually using Arc on Windows for a bit recently. And it's really a great app. It works great. And I'm no expert on what makes Windows app feel truly native, but it certainly looks absolutely fine to me. I wouldn't be able to tell a difference.
Well, they are using that they are using the native APIs. They're using Swift bindings into WinRT, which is the native Windows API.
Yeah, exactly. Yeah,
so it should feel native.
It should absolutely. I just wonder, sometimes it might not cover everything, so you might see some oddities because certain OS level things that are typical aren't available, and there might be workarounds. That that's the sort of thing I was thinking about.
Yes.
But there's none of that. But then again, I probably wouldn't be a good judge of it anyway. So, but the post isn't really about Arc. I don't think it even mentions Arc. It talks about what tools they use to develop Arc, which is obviously VS Code as the editor, as the IDE. They go on to talk about the debugging, what they use, the LLDB. But also that you can use Windows native debugging tools that aren't specific to Swift, and they can be made to work with this. And they also go a bit into how you can use obviously Swift PM, and that's what they use mainly to build the binaries. But you can also use CMake if you have special requirements that aren't covered by Swift PM, that sort of thing. And that might be related to Windows APIs that you need to integrate with, or Windows libraries that you need to integrate with, or issues that might need to work around, because on Windows there's a 64K limit in terms of, I think, how many symbols you can export in a DLL. And for that reason, I think that's the reason why you need CMake to build and to strip out stuff that you don't need to actually ship in a DLLs. It's an interesting post, even if you're not developing in Windows, just to see how stuff works over there. And I found it a nice description of how that goes. And I'm actually particularly interested because I'll start poking at this a bit with Swift on Windows in the near future. One interesting other thing I saw mentioned is they talk about tools, Swift tools that are shipped with a compiler. And one thing in particular is Swift Inspect, which I don't think I'd heard about before. And there's a subdirectory inside the Swift compiler with tools, and that's where this lives. It's not a separate package. It is a package, but it's embedded in the Swift repository, and it's a tool that allows you to inspect a live running Swift process and dump some info. It's not like the info is very specific. It's quite niche, so you can like array information and cache information, that sort of thing. But I found it interesting that there's stuff in the compiler that's shipped as Swift packages, and it might also be interesting for people who are poking around and might want to see how that sort of stuff is implemented. That's why I wanted to give a shout out to that particular tool. So interesting stuff there coming out on non-Apple platforms.
Yeah, it is.
Finally a bit of news that is about performance benchmarking. So it was a long Swift forum thread about performance benchmarking, and
I did see this one. Yeah,
you saw that one. Yeah, I think it was hard to miss. I found it really interesting for a number of reasons, and they're probably not all obvious. It all started when Axel Rost posted a benchmark result and asked for help on the Swift forums, and it's about understanding the results that he saw, which were weird. So he used Vapor, a Swift server framework to run the performance. I should say what the performance benchmark is about. This is about running a web server, web framework, and to test its requests throughput. How many requests can it handle per second, and compare different languages and and frameworks like Node, PHP, I think, and Python are the three other language framework combinations he looked at. And he saw interesting results in general, but in particular he saw that Vapor Swift was dropping 1.5% of all requests, which is odd, and off the start without any load. And that's the question he asked on the Swift forums. And if you've ever seen a nerd sniping of epic proportions, that was one, because everyone sort of
accused of dropping requests. Yeah,
this was and then people obviously also looked at the performance, the benchmark itself, because that was also quite low. Like Swift wasn't doing great in terms of request throughput, which seemed odd because there was nothing really that should make it, it should have done better, I think. And it did in the end. But it was really interesting to see how there was not one single thing that was wrong, and obviously wrong. And it took a lot of really skilled people to poke at it to find out what was going on. And I think it's really hard to summarize the results here, because there were so many interesting outcomes and questions being asked and investigated, and sort of assumptions being tested and revised. It's an interesting thread. I think one of the things that came out of it was your benchmark methodology is really important, and was somewhat problematic here, because he was creating load as the benchmark and then testing something slightly different when what he thought he was testing. And that was partly a problem was on Swift, that in order to create the load, he used a third-party dependency in order to compute the thing that he would use the Fibonacci sequence to create the load, but the package used to do that on Swift wasn't actually well maintained. It was quite a lot slower than the other implementations, which used native, highly optimized implementations of BigInt to do that thing. So that was sort of not a like-for-like comparison. Then Vapor had a default config, which wasn't ideal for this sort of test scenario, and perhaps even in general. There were some system limits on the OSs that he tested that were too tight, like maximum file descriptors and maximum outstanding socket connections being allowed. So that was interesting. And that wasn't just macOS, also Linux. These should have been tweaked in order to make this a decent, a normal test, like you would normally test this, because you don't want to test the system limits, right? You want to test the framework limits. So that was just, I think I listed 5 there. There might have been more, but it's just a really interesting thread about performance benchmarking, and like how predictably it'll attract lots of interesting discussion. And it was, I think it is notable that this was a good discussion. It was a really interesting discussion.
Well, that's what I was going to say. Yeah. I thought it was really, one thing that was really struck me in read. I didn't read the nitty gritty of every post on it, because it was an extremely long thread in the end. But what I thought was really nice was how not only the people from the Swift side, but the benchmark, the person who was running the benchmarks, was willing to accept that neither side was perfect in their initial kind of testing, where sometimes, and I'm not accusing this of anyone in specific here, but sometimes people produce a benchmark to prove their point, and once their point is proven, it's hard to move them away from that original kind of benchmark. But I thought this was a really great example of collaboration between people.
Yeah, and it's also, I think it's also the proposition of the benchmark is really important, because there's different ways of going at it. You can test default config and make the argument, well, that's what people are going to use, right? I mean, lots of people, obviously Google, Apple aren't going to use it like that, because they know how to test the best possible case. So you think you always need to have almost like 2 benchmarks. One is the default, which people will use, and which will be seen in production, because that's what people start out with. And then perhaps at the other end of the spectrum, the one that's tuned to the gills and everything is taken care of, and every little bit is tweaked, and that's what you look at as well. But I think neither is perfect in assessing what will be the result for you to choose a framework, because I mean, we run a web service and we use Vapor quite a bit, and we sort of look at stuff, but we are using the defaults. I don't think there's a lot that we've tweaked. So if there's anything that we would benefit of the defaults changing as a result of this. And I think that's why these default testing benchmarks are also really important, because you have a huge impact if you make improvements there, because all the people using the defaults will see that benefit trickle down. But I think the real summary should probably be only trust the benchmark where your favorite language framework comes out on top, isn't it?
Sure. Well, that was kind of my point. Yeah, like once you've proven what you thought you were going to prove, why do anything else, right?
Stop right there. Exactly. Yeah.
Should we do some package recommendations?
Yeah, let's do it. Do you want to kick us off? Because I really have only 2 this week.
That's okay. We can do 2 each. I can kick us off with a package called Swift Chess Neo by Navan Chowan, which is a cross-platform Swift chess library. Now, I'm not a big chess player. I can just about struggle through a game, but don't talk to me about tactics. And this is a work in progress library, which is actually a fork of a package called Sage by, I should have had this information ready, by Nikolai Vasquez, which is a no longer maintained Swift package for cross-platform chess. And this Swift Chess Neo is a fork of that, along with some patches from someone, and it also adds SwiftUI views. But what does this package do? It does much more than just visualize chess, which is the SwiftUI bit of it. It does game management. It does move execution. It has all the rules encoded, of course. It has move generation. So it would be possible to build from this package into a chess game. And in fact, the person does say, Navan does say, I'm actively developing Swift Chess Neo while writing I Watch Chess for iOS and macOS. So this is the core logic for an app which is being produced at the moment. And it can also do visualizations in ASCII, so you can look at the board while you're debugging, and it will print out an ASCII representation of the chessboard, and it understands all of the chess notations, so that you can input your chess moves in with a notation rather than having to deal with an API, which would not be as efficient to kind of code against. And I thought this was just a really nice example of a little package that most people won't see. Yeah, if you've ever any interest in chess whatsoever, I think you'd find something interesting here.
So the package is called Swift Chess Neo, and Neo is
NEO, yeah.
NEO, yes, because until about halfway through of your description, I was sitting here thinking, what on earth does chess have to do with Neo?
How is the network going to get involved?
Yes, I was like, until you said SwiftUI, then that's when it sort of started clicking, and I thought, oh, right, the other Neo. That's really interesting.
In Swift 7, all network requests will have to go through a chessboard representation before being executed.
I'm really curious what the transcription is going to make of this segment.
Yes, yes, that will be a good test of Whisper's AI. But yeah, it looks great, and it's not NIO, it's Neo NEO.
Excellent, that's
like the man from the Matrix.
Nice. Right, my first pick is called Swift Security by Dmitry Zarov. And it's a Swift API layer for Apple's security framework. So that's Keychain API, Shared Web Credentials API, etc. And so I've been using a sort of a keychain wrapper in some of my command line tools. And that's sort of like a wrapper. It's just a single file that abstracts over the keychain APIs, which are a bit awkward. Like they're very C-like. I think they're I'm not even sure if there's any glue in between, or if you're really just calling into the C directly. But you know the ones I'm talking about, right? The sec item stuff where it's like a really non-Swifty API. So I had this file. It's been a while since I wrote this, and I would probably switch to this instead. which has a really nice Swift API, not just for the keychain parts of it, but also all these other parts of security framework. So it looks like a really complete wrapper around this, and yeah, a nice package for this. And I know there's others. The package index might be a nice place to look around if you have needs for that. You might not need the full security framework, maybe just the keychain API, but this is one that does all of it and might be worth checking out. So that's Swift Security by Dmitry Zarov.
It's interesting that in the APIs where Apple could have made a new keychain and security API that fitted in slightly better with Swift, and in those areas where that hasn't yet been done, or it's maybe not been done to the community's satisfaction, you'll see a collection of packages, and there are so many keychain packages. Actually, I wonder if Apple could use that as an indication of where they need to focus attention.
Absolutely, it's a blossoming of packages on the fertile ground of C APIs, isn't it?
Exactly. Yeah. But yes, there are lots of them. But this one sounds like a good one.
Yeah.
My next package is by David Beck, and it's called Swift Glob, and it's a native implementation of Glob pattern matching. So the Glob pattern matching that you can do in a file system, where you can do like */*star.swift or whatever, it brings that into a Swift UI, not your Swift UI, but a Swift user interface, an API user interface, where you can very quickly include and exclude globs from a search in a directory. So you pass it a directory, you pass it in a set of patterns to include and a set of patterns to exclude, and you would get back a list of files that match the combined set of everything that you've passed to it. And I think there's obviously lots of ways to filter the files you get back from the file system, but globs are something that have been around for a long time, and they're a really efficient way to represent file system searches that I don't think anything else has come close to. So it's nice to be able to use that inside a Swift application.
Yeah, it's nice, right? Because it's just familiar, right? You know immediately how to use that, but without understanding, the regex syntax and that sort of stuff. I mean, probably if you have very specific needs in filtering, you might need more, but it's just such a well understood concept that it's nice to see that being available. Nice.
And so it's a fairly new package, and it only has 9 stars. So if you are interested in globs, go and give it a star on GitHub.
Nice,
because it's the kind of thing that this is a perfect use for a package. This is something that's you're not going to build your whole application on this dependency. So it's easy to replace if it turns out not to do what you want it to do. But it's going to save you time if you're doing lots of file system querying.
Yeah, absolutely. Right. My second pick comes in the shape of a blog post, actually. So I'm sneaking a blog post into the package pick section.
This is one of my famous non-pick picks.
Well, it is a pick, so you can use it as a dependency. It's just not. It hasn't been packaged up yet. maybe this is encouragement. Although I think the author is quite busy. The author is Rob Napier, and his blog post is about any coding key. That's what he calls the thing, the type that he implemented. It's a really interesting blog post. He looks at explores the coding key protocol and what it means to conform to it, and especially if you want to conform to it yourself, other than like you normally would with a string-backed enum, right? We all know this. If we have, for instance, a thing that we want to decode, and the property name, we want to have a property name on the Swift side that's different from the property name in the JSON, for instance.
Right.
what we do is we have an enum that conforms to coding key, and then we spell out the cases, also the ones that we don't want to change. And for the ones that we do want to change, we give the case name. We assign a Swift case name and assign it a stringified, the string of the JSON attribute name that we want to map to it. So that's what you normally do. There's a bit of repetition going on there because you need to spell out all the other cases that you don't want to change, but yeah, that's just the way it is. And Rob explores what it means to implement this any coding key thing that allows you to do that a little bit more elegantly, more concisely. And it's a really nice thing. It's a tiny type. It really, like, my package recommendation is effectively a code block in a blog post. so you can copy that out. And there's a second code block that makes it even nicer with an overload or an extension on JSON decoder to make that nicer. And it's all lives in a repository, but the repository isn't the package. It's a collection of, I think there's playgrounds in it and just code snippets that explore more around Codable. That's definitely also a thing worth looking at. So the whole thing is a blog post and also a protocol, not a protocol, a repository that Rob has prepared with lots of examples and stuff. So take a look. Any coding key by Rob Napier.
All it needs is a package.swift.
Yeah, get working on that, Rob.
Or somebody else. It doesn't have to be. Rob.
Exactly, with attribution. Of course.
Although it's always interesting because if you publish code on a blog, what license is that code being published under? I mean, it's technically not an open source license unless explicitly stated. So just be careful. Be careful taking code off people's web pages. Or I'm sure this is provided in that spirit.
You're listening, OpenAI.
And with that, I think we'll wrap it up there. So we will be back in a few weeks with another episode, and maybe by that time we will have in fact, I'm pretty sure by that time we will have the new build system in production, so maybe we'll talk more about it then.
And we should have the Swift 6 preview site live by that as well, shouldn't we?
We'll definitely have the Swift 6 preview live by then, yes. Yeah.
Well, we got ourselves 2 deadlines then.
2 deadlines, yeah, before the next episode, but we haven't said when the next episode will be. So,
well, there we go. That's our escape hatch.
All right, I'll speak to you in a few weeks.
All right, see you then. Bye-bye.
Bye-bye.